Hello everyone, welcome back to another video for the series. I'm Yu, and today I brought a very interesting problem from Baltic way because I think this problem taught me how important it is to utilize the fundamental ideas. So yes, let's get into it. So what I mean by utilizing the fundamental idea is not doing some advanced stuffs, but just trying those things that are like quite simple. And there are things that we need to do when we see a functional equation problem. And the first thing is when x equals y equals 0. This time we get f of 0 equals f of 0. So this is something. Now the next fundamental thing that we normally do is substitute x equals 0. So we have f of 0 plus y equals f of y plus y f of y. And as you might have guessed, the next thing that we usually do is substitute y equals 0. So there's no like advanced stuffs, but just like the things that we all do. And then most of you might know this, but we will still try this one. So we have f of x plus f of x equals f of x plus f of x plus f of x f of x. Yes. Now we have this for information and for piece of information and for pieces of information, sorry. And we want to utilize it. So how should we do it? And here I think it's the part where we need to be smart, and we must have good eyesight to do this. So first of all, we should notice for any pattern or any terms that appears a lot. So notice that we have x plus f of x, x plus f of x, and x plus f of x here. So why don't we try letting f of x plus x equals a. So like let a equals x plus f of x. That way we know that f of x is equal to f of a. Now this is the same thing as f of we're going to substitute it back here. So when we substitute a here, we get f of a plus x. Oh, sorry, a. Now notice that this is the same thing as f of a, which is f of x, plus x plus f of x. Now, does it look familiar? Yes, we have it right here. So this is equal to f of a, because this thing is a, plus f of x, f of x. Now the reason why we wanted to make this f of a is because we know that this is equal to f of x plus f of x, f of x. And notice that this is f of x. Now we have a beautiful thing here. This two cancels off like this. So we have f of x times f of x equals 0, always. Now the reason why this is always true is because we just randomly substitute numbers, and because any function f of x that satisfies this general equation satisfies specific cases, it must also satisfy this one because it's if-then condition. Therefore, let's try this one. We know that f of 0 is equal to f of 0. So substituting 0, f of, because this is true for all x, equals 0, and therefore f of 0 equals 0. So this is true. Yeah. Now, yeah. Let's utilize this equation because we used this one, and this one, but we have not used this one yet. And notice that f of 0 equals 0. Therefore, we have f of y equals f of y plus y f of y. In other words, f of y times y equals 0, always. So this implies that y equals 0, or f of y equals 0 for all y not equal 0. And y, of course, real numbers. Now, we also know that f of 0 equals 0. That means, using this fact and this fact right here, so because this is always true, we know that f of x is equal to 0 for all x in, yes. So basically this is our solution, f of x is equal to 0. And I think this problem is really interesting in a way that it reminds us that it's really important to look at the basic steps first, substituting x, y equals 0, x equals 0, y equals 0, y equals f of x, because those are the only things that we did, except for noticing this pattern. So instead of like trying, so this problem taught me that instead of like looking at the symmetrics, looking at the other steps first, we need to try the basic things first, because after looking at this, I tried substituting like x equals negative y, because I mean many people try that first too, and I also saw x plus y, so that was like quite the obvious thing that I did, but I was not able to get much information from there. So I think this basic substitutions were really useful. And yes, and how do we ensure that this is the only solution? And that's because, as I mentioned, I think this is also really an important thing in function equations, to prove if and only if condition. However, notice that every f of x that satisfies this general equation right here also satisfies this individual cases, because they are the specific cases from generalized form. So if a function satisfies the generalized form, it satisfies all these specific cases. That's what it's saying. So it must satisfy this one, this one. So these are all true. So these four equations are all true. And using two true equations, we got another true equation right here. F of 0 equals 0. And we utilize the true and the true together to get another true. And this are the same statement, and we know that this and this merges to this one. So we get f of x equals 0. So this is true. Yeah. And we actually have not missed any information, because all the information are preserved, because every f of x must satisfy all the equations listed here. And if they satisfy all of them, then it also must satisfy this one. So even though it seems like there might be another solution, this is the only solution. So this problem really taught me a lot to use basic ideas, and I think it was really an interesting problem for me. Thank you, and I'll come back with another very fun and interesting problem tomorrow. Thank you, and see you tomorrow. Bye.